Madam, PPT is visible, madam?
Yes, sir, both. You also visible and PPT also visible, sir. Everything fine, sir. We will
Okay,
start in
okay.
1 minute, sir.
Yes, madam, yes.
Thank you, sir.
A very warm good evening to all dignitaries, guests, and delegates with great joy and immense pleasure. I, Dr. S. Rukmani Devi, Assistant Professor from the Department of Computational Intelligence, Savita College of Liberal Arts and Sciences, feel privileged to extend our warm welcome to you all who joined here for the fifth day of 5 days International Virtual Faculty Development Program Series 2 on Hybrid Education with Pedagogical Success. Savita Institute of Medical and Technical Sciences, CIMATS, is proud to share with you all that our CIMATS has been re-accredited by grade. Savita College of Liberal Arts and Sciences to emerge as a leading institution by providing quality global standards education with a research culture and developing persons with ethical values to serve society. On behalf of the Department of Computational Intelligence, Savita College of Liberal Arts and Sciences, we extend our profound gratitude towards respected Chancellor of CIMATS, Dr. N.M. Virayan Sir, respected Director, Academics, Dr. Deepak Sir, respected Director Madam, Dr. Ramya Deepak, and Vice Chancellor, Dr. Suresh Kumar Sir. We wish to express our heartfelt gratitude to our Principal Madam, Dr. Gunita Arun Chandok, who encourages every faculty and student. Now, I'm glad to introduce our guest speaker of the day, Dr. V. Thirunavukkarasu. Dr. Thirunavukkarasu has 15 years of teaching experience, currently working as Assistant Professor at Christ University, Bangalore. He is a doctorate in Computer Science and Engineering from Bharatiyar University, Coimbatore. Dr. Thirunavukkarasu was conferred with several awards, honors, and recognitions from various international and national research associations. He has received Best Researcher of the Year 2019 for the overall excellence in the institution research activities from Rewa University, adds feathers to his cap. He received research grant of rupees 7 lakhs from Vision Group of Science and Technology and Science and Engineering Research Board. Dr. Thirunavukkarasu has published 5 patents and authored books and book chapters in reputed journals. He has published 20 research publications in international journals and presented 12 research articles in international conferences and Scopus Index journals. He has organized and presented and participated in several conferences, workshops, FDPs, and seminars. We welcome you, sir. Now, the time is over to our guest speaker. Sir, please, the time is yours.
Yes. Thank you so much for your nice introduction, madam. First of all, I like to thank Savita College of Liberal Arts and Science, the management who provided the platform for us to conduct this type of FDP program for our faculties. And I like to thank Dr. Jayakartika, Madam, Associate Professor and Head, Department of Computational Intelligence, Savita College of Liberal Arts and Science, who invited me for this FDP program as a resource person. I like to thank Madam and the management of Savita College of Arts and Science. So now I will present my topic. Today's topic of my presentation is computer vision. So when you say computer vision, the question will come to us: why computer should have a vision? We have a human vision. Human have a vision. Every organization or institution have a vision. Why computer should have a vision? Because computer will not think anything, but we can make the computer to think. But why should computer should have a vision? This question will obviously come to our mind, and why we need to research in that particular area. So this, I think this 1 hour of time, I'm going to introduce about these topics. So first of all, I try to introduce about image processing, how image processing is important before learning the computer vision, and what are the limitations of our human vision and computer vision system, and different levels of computer vision system. That is, we have low level, middle level, and high level vision system, and plenty of research opportunities in this particular area called computer vision, and steps in imaging, image processing, analysis, and understanding. So this is my idea about today's presentation. So, the question will obviously comes to our mind: why we need to have a computer vision? Because if you wanted to see the world around us, if you wanted to interpret the world around us, if you wanted to understand the world around us, we need to have some vision. Because when we call someone is a visionary, then he is able to see what other people cannot see. The rest of the people cannot see in the world. That is why we call them as a visionary. So similarly, if you are suppose if you are given an image, for example, consider that you are given a medical image, you wanted to identify a particular kind of tumor. Then we wanted to identify the location of the tumor and what is the nature of that particular tumor and different stages of this tumor. Then the human vision fails in this case, because human vision has certain limitation. I will tell you what are the different limitations of the human vision later. If you wanted to understand the image, if you wanted to interpret the image, if you wanted to analyze the images, and after that only we come to the conclusion that whether that particular tumor it belongs to certain category or not. So before that, so that is
Excuse me,
similarly.
sir.
Yes, madam. Yes, madam.
Kindly move the screen, sir. Sorry to disturb.
Yeah, I moved, madam. Yeah, I'm moving. Can you hear
Okay,
me?
sir.
Can you see that?
Thank you.
Yeah, I moved.
We cannot able
So-
to see the next screen, sir.
Now?
No, sir.
Just a minute. Now, madam?
No, sir. Main screen only
No.
we can able to see. Okay, sir. No issues. You can proceed, sir.
Just a minute, I will try it.
Send your PPT, sir. We will share the screen.
Yeah. Yes, madam. Which email ID I have to send, madam? Hello?
I will send it about.
Madam, I sent, madam. I will stop sharing my screen. Hello.
Yes, sir, you can share. Yes, sir, you can stop your screen and we will
Okay.
share, sir. But you cannot receive your mail. Still, we can't receive your email, sir.
It is delivered. Okay. Just a minute. Madam, can you check your email now? Madam, have you received?
Yes, sir, received.
Okay, okay. Okay, can you share that PPT?
Yes.
Okay, sorry for the interruption. Shall I start, madam?
Yeah, sir, you can start. Thank you, sir.
Okay, thank you, madam. Okay, so before learning computer vision, we should learn what is image processing and what is the necessity to process the image. You should all of you know about how we are processing the image in the spatial domain, how we are processing the image in the frequency domain. So these are the basic concepts we need to learn before learning the computer visions, because various computer vision techniques will make use of the image processing techniques and algorithms. So image processing is the prerequisite for learning your computer vision. And for example, then what you may ask the question, what's the difference between image processing and computer vision? For example, if we have an image, then we are enhancing the quality of an image for the better visibility. Then we call it as this is an image processing, because we wanted to improve the clarity of an image. That is why we are enhancing the quality. And this is focused only on the low-level features. The image processing concept is focusing only on the low-level features. But suppose if you wanted to interpret the scene, or if you wanted to understand the scene in the image, or you wanted to recognize a particular object in an image, then we go for a computer vision concept. So that's a major distinction between the image processing and computer vision. Moreover, we are using all image processing techniques in computer visions also. So before learning, image processing is very important. Madam, can you please move next slide? Can you move to the next slide? Yes. So I earlier told that there are some limitations in human vision system. That is why we are going for computer vision system. So the human vision system has certain limitation. For example, limited spectrum. Only within a particular wavelength we can able to see the objects. Beyond that or below that particular wavelength, we cannot able to see the objects or recognize the object, and we have only limited amount of memory. We cannot remember all those things. So so that is why we are moving to computer vision system concepts. Then image processing is one part of our computer vision. So then you can elaborate the computer vision as making the useful decision about the real physical objects and scenes based on the images. So you wanted to make a particular decision from the image. For example, you are given on medical image. So from that medical image, we wanted to make a decision stating that whether that particular tumor is a cancer tumor or not, or what is the severity of that particular tumor, whether the tumor is the initial stage or middle stage, or whether it is in the advanced stage or not. We wanted to classify those things. So in that case, we need to go for computer vision concept. And extracting the descriptions from the images, we using the computer vision system, computer vision algorithms and the techniques we are using. And suppose you are given a agricultural image. For example, in the field of agriculture, we are taking some picture of a leaf. We wanted to identify the disease, what type of disease it is, what is the stage of that particular disease, the type of that disease, and etc. So in that case, the normal vision system or normal image processing techniques will not help us to predict or to come to the conclusion. So that is why we are moving to computer vision system concept. Similarly, in the satellite images also, we wanted to segregate the different parts of the images. We wanted to track a particular object in an image. Then this computer vision system will help us. So this diagram will elaborate it, what is that image processing and scene analysis. For image processing, we are preparing the images for scene analysis. So scene analysis is higher level of our image processing, and from that scene analysis, we are building a model, and from that model, we can able to predict when the new images is applied to our system, we can able to predict it. Another major distinction between the image processing and computer vision system concept is in image processing, it may be both the input and output will be an image. But in a computer vision, the input may be an image, the output may not be an image. It may be an attributes of images, because we are analyzing the images, we are extracting the features, we are analyzing those features. Finally, we are coming to the conclusion. We are understanding the scenes, we are understanding about the images, or we are interpreting the scene. So that's a major distinction between the computer vision and image processing. And if you see this, madam, can you go to the previous slide? Okay. So it is mainly involves the segmentation, recognition, and reconstruction. Segmentation, various techniques we come across in the image segmentation. For different segmentation techniques are available, starting to for example, region-based segmentation, and morphological-based image segmentation, and somewhere we are using water set segmentation, active contour segmentation. Different segmentation techniques we can make use of it to segment the part of our images. The computer vision will make use of the image processing and machine learning outputs, as well as some more mathematical methods also. And we are broadly classifying the computer vision system into three systems, that is three levels. In the first level, we call it as a low level vision. So here we are processing the image for future extraction. What is a future, what is a necessity to extract these features. So while extracting the features, we need to concentrate on the invariant about that particular features. For example, we are extracting a particular features, whether that feature is invariant against the geometric transformation or other image distortions or not. Because image is distorted because of so many reasons. While acquiring the image itself, there is a possibility that the image may be blurred. So before process, we cannot process the blurred image. So before processing that image, we need to remove that blurring effect in the image, as well as image is contaminated by the different types of noises. Then we need to remove the noises using the appropriate filters. Afterwards, the image is taken for processing, because this will affect the prediction accuracy of our algorithm or prediction accuracy of our system. These noises and other distortions in the images will affect. And while extracting the features, we need to concentrate more on the invariance, that is how far the features are invariant against the geometric transformations and other image distortions. And in the middle level vision, we have object recognition, motion analysis, and 3D reconstruction using features, because we are capturing a 3D object. The 3D object is converted or projected into 2D plan in our camera. So now we need to learn about the camera intrinsic fingerprints and camera's extrinsic fingerprints in order to project the 3D objects into 2D plan. And normally, when you are capturing the images in the 2D format, that is a 2D object, we wanted to extract the 3D structure of a particular object. Then we need to go for higher level of vision. That is, for example, we wanted to structure from motion. We have a different types of images. Same scene is taken with a different orientation. Finally, we are combining all these images as a whole. Then we are extracting the full features from the images in order to extract a 3D structure of an object in the image. So in the middle level vision, we'll have object recognition, motion analysis, and 3D reconstruction using features obtained in the low level vision. So this may be performed with extracting the features as well as by means of camera calibration matrix and all. Then the high level vision is nothing but our interpretation. So what we understood from that images, after extracting the features, matching the features, then recognizing a particular object, it's not enough to recognize a particular object. What is our interpretation? For example, if you are given a medical image and we are analyzing the image, we are extracting the features from the image, matching the features. Finally, what is our interpretation? That is about that particular tumor. We need to provide a result, whether the tumor belongs to certain category, what is the level of the tumor, what is the severity of the tumor, and so on. So this is called our higher level of vision. So the interpretation of the evolving information provided by the low level and middle level task. So that is called higher level vision. So these are the three types of vision we should know. And this diagram, if you see this slide, the first one is a classification, and the second one is classification and localization, then object detection and instance segmentation. So in the first two pictures, we are detecting only a single object. We are detecting the single object. And in the third and the fourth images, we are detecting the multiple objects. That too, in the third image, we are detecting the rectangle. We are drawing the rectangle. We are using some other segmentation techniques. So this segmentation techniques will segment along with the background as well as the nearing objects also. We cannot exactly segmenting the particular object in the image. But if you see the fourth image, we are identifying the boundaries of each object exactly, because the objects here, the objects are touching each other, and suppose sometimes there is a possibility when the objects are overlapping each other. In that case, we use the appropriate segmentation technique. Here we need to identify which segmentation technique is proper to segment these kind of images. Suppose if you take watershed algorithm, this is used in image segmentation technique. Especially we are using that algorithm when the objects are overlapping each other in the images. So this algorithm will work better. Suppose if you are taking a region growing algorithm or region merging algorithm, so this algorithm will take one point as a initial point or seed point. So from that point it will grow. It will identify the neighboring pixels and it will grow towards the object boundaries. So when it reaches the object boundaries, the evaluation of the algorithm will stop when it reaches the object boundaries, because there is a drastic changes in the pixel values in the object boundaries. So that is why while detecting the edges also, we are using different techniques to detecting the edges. What are the first order derivative, second order derivative methods, and optimum edge detection method. Many methods we are using to detecting the edges. So the edges basically will be identified based on the pixel variations. So normally in the border of the object, the pixel is varying drastically. So in that place is identified as an edge. So while choosing, while segmenting an image, we need to choose an appropriate segmentation technique in order to segment the object exactly. For example, if you are using region growing algorithm or region merging algorithm or thresholding technique or watershed segmentation technique or active contour methods. So these are the different algorithms in segmentation. Other than that, we will have some other algorithm, that is graph-based segmentation algorithm, normalized cut, and k-means algorithm is also used for segmentation techniques. So different segmentation techniques we need to learn to exactly segment the object from the image. For example, if you take an active contour method, that instead of using the pixels, our watershed segmentation techniques and all will make use of the pixels, but here the active contour we are using curves. Instead of pixels we are using a curves, and the curve will evolve towards the object boundaries. When the curve reaches the object boundaries, the evaluation of the curve will stop. So here we need to estimate the energy of the curve, internal or external energy of the curve. We need to minimize those energy. That is our objective. So depending on the images, what type of images we are having, we have to choose an appropriate segmentation technique in order to segment the object from the image. And these are the various applications of computer vision, and I will tell you some of the research opportunities in that areas. So the first one is optical character recognition. Most commonly we are using this OCR system. Whenever we are reaching the toll gate, automatically our number plate is recognized by the system which is they already installed in the toll gate. They are not writing their numbers, car numbers or vehicle numbers. Automatically it is recognized. Or else, suppose if you are scanning a document, scanning a text document, then after scanning the text document, we wanted to recognize the text. We wanted to recognize the text, or we wanted to recognize a particular digits, then we need to have this OCR. This technology is to convert the scanned document to text, and if you have a scanner, it probably came with the OCR software. Nowadays, the scanner will come with the OCR software itself. That software itself, it will scan the images, and from that image we need to identify the characters. For example, sometimes we have an image is with the object as well as the text. We wanted to segregate the text part alone. Then after segregating the text part, we need to recognize the characters. Then we go for this OCR. And madam, can you move the next slide? Yeah, these are the challenges in OCR, where here we can, these areas we can concentrate. So text is blurred or distorted by the shadow. So this is the first biggest problem in OCR. Suppose even the images is blurred, we need to use appropriate deblurring technique in order to remove the blurring effect in the images. So that is why we can exactly recognize the text. The first challenge is text is blurred or distorted by the shadows. So in that case, we will concentrate in that particular area. And the text and background color is similar. So these are the second challenges. Suppose the color of the text and the color of the background, we need to separate these two things appropriately. And the portions of the images are cut off or cropped. So in that case, how exactly we need to classify that text. And marks on the top of the sum letter, because when you are scanning a written document, there are some problems after while recognizing the scanned document, because different font styles or different sizes the user is writing the text. So if you are recognizing these different things or different font styles, then we need to have an appropriate system or appropriate algorithm to categorize these things. And the various font types and sizes may be difficult to identify. Then the lighting condition, poor lighting condition will impact in the recognition of the text. Suppose you are installed a camera and OCR recognition with OCR recognition system, then how this camera is taking the picture under the different lighting conditions? Because you know that we are using different lighting if you're taking a same scene with the different lighting conditions, and if you're extracting the features from the images and finally you're comparing these features, the feature matching algorithm will fail. Even if the same scene, we are taking in a different lighting condition. That is why we need to consider the gradient of an image. So how gradient of an image, suppose if the same scene is taken in the different lighting conditions, and if you're extracting the feature and matching these two features, the matching algorithm will tell us these two features are different. That is, these two images are different. So in order to avoid that, we need to have we need to identify an appropriate feature extraction algorithm. That is these are the different challenges here. And the next one is this face detection. So you know that obviously 10 years back we are all signing in the attendance register every morning and evening, 2 times we are signing in the attendance register. Nowadays there is no role of attendance register. Everywhere we are installed the face recognition system or fingerprint recognition system. So this system will help us to recognize a particular person. So this is another application of face detection and object detection and object recognition also. So this is the most important area we can concentrate, that is object detection and object recognition. Suppose you are given an image, you are given a satellite image, then how will you categorize the different parts of your satellite images? So what are the different challenges in detecting an object in an image? Then suppose if you are given a medical image, how you are going to categorize the different parts of the medical images, and finally how we are interpreting that particular images based on your low and middle level vision. And I will tell you what are the different challenges in this object detection and recognition in the next slide. Madam, can you move to the next slide? So these are the different challenges, previous one. So these are the challenges in the face recognition. So your system will be able to recognize the face under different lighting conditions, and misalignment in the face or variations in the poses also, irrespective of the poses or irrespective of the variations in the face, then your system will be able to recognize the faces. And occlusion is another challenges. So while developing these systems, we need to concentrate on these 3 challenges. And opportunities in object detection and recognition. The first opportunity is identifying and implementing the appropriate feature detection and extraction method. You know that what is the feature, what is the necessity to extract different feature from the images, and which feature is appropriate for a particular applications. We need to know those things. And while extracting the feature, which feature is better suited for our application. For example, line is a feature, point is a feature, edge is a feature, texture is another feature, different color is also a feature. So different features are there. We are extracting the images. Then we need to identify an appropriate feature for our application. And moreover, that feature is whether it is invariant against the image distortions or some kind of geometric transformation. Suppose your task is you wanted to compare the two images, or you wanted to identify whether the image is tampered or not. So in that case, a particular part of an image is copied and pasted in the different part of the same image. So in order to hide these traces of tampering, normally the tampers will do some kind of distortions, image distortions, or some kind of transformations. For example, they will enlarge the size of the image or part of the particular object, or they may be rotating that particular object in a particular angle, or they may be increasing or decreasing the size of an image, or they may be flipping that particular part of an image, or else they will do some contrast enhancement or brightness changes or color changes, something like that they will do in order to hide the traces of tampering. So while extracting the futures, we need to concentrate on the invariance of our futures, whether these futures will work even after that geometric transformations and image distortion and all. So that is the first challenge. Madam, go back to the previous slide. Madam, can you go back to the previous slide? No, previous slide. Yeah, this is, so that is the first challenge. No, previous one. Previous slide, madam. No, previous. Yes, this one. Then, no, next. Next slide. Yes, the second, no, madam. Yes, this is slide. So next one, reducing the computational complexity of the proposed method. So the computational complexity of our algorithm is purely depending on the dimension of the futures. While extracting the futures, we need to concentrate on the dimensionality of the futures, because all futures are not equally important for our applications. Only relevant futures we need to extract. So for that, we will have a different dimensionality reduction techniques. Linear dimensionality reduction, non-linear dimensionality reduction techniques are there. So we have to identify which dimensionality reduction techniques will better suited for our application in order to reduce the dimension of the future, because it will affect the computational complexity of our algorithm. So that is the second challenge, is to selecting an appropriate futures or relevant futures from the image is the most important challenge. Then third one is enhancing the accuracy of the statistical classifier by reducing the wrong classification. Always our system will have a false positive, false negative, true positive, and true negative. So based on that only we are computing the accuracy of our system. The accuracy of a system is purely depending on these four metrics. So how we can reducing these false positive and false negative and true positives and true negatives. So that is the another. Hello, madam, can you hear me? Hello, madam, can you hear me? Okay, can you go back to the previous slide?
Yes, sir. Now we
Ah,
are there.
yes, madam. There is a connectivity problem from my side.
Okay.
Can you go back to the previous slide? Previous one? Previous one. Yes. So, yeah, next one, next one. Next slide, madam.
So
Yes,
kindly
madam.
wait for a few seconds, sir.
Okay. Previous slide. Yes, yes, this one. Okay. So the other challenge is finding in object detection and recognition is finding and classifying the object irrespective of the scale, location, or pose or illumination changes or geometrical and a different image distortion. That is another challenge. That is why before selecting the future, extracting the future itself, while using a future detection or future extraction algorithms, we need to know whether these features are invariant against these different this image distortions. For example, if you take a surf algorithm, there is an algorithm called a surf algorithm. If you extract these features, surf features is invariant against our geometric transformation. That is, even if the particular object is scaled or the particular object is rotated or the particular object is translated from one place to another place, it will extract the same kind of features. But if you take other types of features, other feature extraction or detection algorithms, it will consider these two features are different. Even though they are same objects, it will show the different features. So while choosing an appropriate future detection and future extraction algorithm, we need to be careful about these changes, whether these features are detecting the same kind of features even after these image distortions. That is another challenging task. We need to concentrate in this area and track an object over an image sequence. Suppose you are given a video sequence or video sequence. In that particular video sequence you wanted to track a moving object and how the object is moving with respect to the background, and suppose multiple moving objects are there, how we are tracking the multiple objects in a scene, and in which directions the different objects are moving, and what are the stationary objects in that particular scene. So these are the another area we can concentrate, and detecting a single object with different pose and views. Suppose I already told that suppose we are taking a same scene with a different pose, different pose. The ultimate aim to combine these different poses and is to extract the three structure of an object, because when you are projecting a three-dimensional object into a two-dimensional plan, obviously we will get a two-dimensional shape only. But from that two-dimensional shape we wanted to extract, or we wanted to extract the three-dimensional shape, then we have to concentrate on this, that is structure from motion. This is one technique which will help us to extract the 3D structure from the 2D image. So that is, and then these are the other challenges. See this 1984, how the girl looks like, and in the year 2002 how it looks like. So it's very difficult to track the faces and recognizing the faces. So that is why we go for iris recognition or fingerprint recognition system. So this, because iris the patterns will not change and fingerprint pattern will not change even if you are using the some kind of surgeries, it will not change. Then the 3D modeling, that is earth viewers, you wanted to move a particular place in the 3D modeling, then that is another important application of our computer vision. The next slide, madam. Can you move to the next one? This is the special effect, that is a shape capturing. So see this shape capturing, same object with the different shapes. So how we are combining these and extracting the features from the different shapes and matching those features. That is another challenging task. So here in the structure from motion technique, either we can make use of the camera calibration matrix or we can make use of the future detection algorithms. Both the ways we can extract the 3D structure of an object. Both the techniques will have their own pros and cons. Then we need to address or identify which technique is better suited for our application. And the next important application is our augmented reality. You know what is an augmented reality. If you see the first picture, the virtual line, where we have to draw that appropriate line, because it is a combination of virtual world and the real world. We nowadays, if you are seeing a cricket match or any gaming event is telecasted, the virtual ad is played in that scene, as well as some virtual line they are drawing and identifying the movement of a player, movement of a player, or movement of how the ball is moved, in what speed the ball is speed he's hitting that particular ball. Everything we are So in the autonomous vehicles, we need to identify an appropriate object detection and recognition system, because it is a driverless car. Whenever it encounters an obstacles in front of it, automatically it has to take a decision of its own. Because there is no human is controlling the system. So this system will automatically identify the obstacles in front of it, and it will recognize the traffic sign also. So depending on the traffic sign, it has to take an action, and it will identify the distance between the obstacles, or some pedestrians are crossing the road. It has to identify the distance between the car and the pedestrian, and how we are controlling the speed of the car, when we have to apply a brake, when we have to apply the accelerator. So many things it has to detect. So we need to make a continuous decisions depending on the images which is captured by the system, as well as it has to give some kind of alarms. For example, the object in front of the car is very near to our it's very near to our car. It has to give some kind of alarm. If someone is touching our car, it has to give some alarm. Or it suppose we wanted to reverse that car, or we wanted to move in the reverse side, we identify what are the different objects in front of it or in the back side of the car. So depending on that, it has to make a decision. So in object detection and recognition system, so autonomous vehicles, this techniques will help us in autonomous vehicles and smart cars, as well as robotic navigation also. We need to make a continuous decisions. Robot has to make a continuous decision depending on the objects they are encountered in front of it. So this is another important applications. Madam, can you move to previous slides? That applications. Back, madam. Next slide. So this is another important application of computer vision. Next, madam. Next slide. Madam, can you move to the next slide? Yes, next one. This is vision-based interaction and games. Nowadays, so many interactive games are available. So these games will make use of this computer vision techniques. And vision system used for example, if it is used for panorama stitching, different images we are combining together, and finally we'll produce the 360-degree view of a particular image. And the 3D terrain modeling. Suppose we are traveling in an unknown terrain. We do not know how to travel it. At what distance we will have the gas station. At what distance we have some mechanic shop. So many things we do not know. So if before traveling, if you wanted to know about that particular place and what speed we need to travel in that particular road, and what are the different stores which is available in front of the door. So many things we will track using these systems. And obstacle detection and position tracking is another application. Obstacle detection, suppose if you take robotic navigations or autonomous vehicle system, obstacle detection will help us to detecting the object in front of it. So that is called obstacle detection, as well as we need to detect the distance between that particular object to the camera, and what is the next decisions we need to take in order to go for the next movement. Then the position tracking is another important application. Then next, madam, next slide. Can you move to the next? Yes. So medical imaging, industrial quality inspection system. So medical imaging, so computer aided surgery nowadays, it is most popular among the doctors. So we wanted to identify the exact location where we need to do the surgery, and we wanted to identify the exact location of a particular tumor, and what is the size of that particular tumor, severity of the tumor, everything we need to predict, everything we need to make a decisions also. The industrial quality inspection system is another important application. For example, suppose if you take a bottle manufacturing industry or other industry, they are installed the vision based system. That system will automatically identify the defects in the bottles. Suppose these defects will not be identified by the human. The machines will easily understand. There is some system which is installed in front of it, so it will capture the image of that particular bottle, identify is there any cracks in that particular bottle. So automatically, if it identifies the cracks, it will reject that particular bottle. Similarly, suppose if you are taking tiles manufacturing industry, they wanted to identify the mild track in the tiles. So here we can install the computer vision system. That system will obviously identify the cracks in the tiles, so that we can remove those tiles from for selling. The next one, madam. Can you go back to the next slide? So agriculture also we can implement computer vision system concept. Madam, can you go to the next slide? Okay, so vision-based robotic learning. Suppose you wanted to make a robot to learn depending on the object it has seen in front of it. Suppose for that also we can make use of the computer vision techniques. That is, robot learn names for the new objects through the gaze following. So whichever object it is encountered in front of it, so it has to learn and store it in the next time. If you see the same object, it will recognize the appropriate object. The next one, madam. So this is a login with your fingerprint or face recognition system. Then this is a challenge. Suppose Michael Jackson image is there. So frequently he make a plastic surgery. Through that he can change the appearance of his face. Then it's very difficult to recognize the face. So that is why we are going for fingerprint recognition or iris recognition system. So these challenges how we are going to address. The next one, madam. This is the various steps in imaging and image processing, image analysis and understanding. So imaging is nothing but acquiring the image by means of certain devices. Different devices are available to capture the images. So after the capturing the images, we need to digitalize that particular images, and sampling and quantization, which is coming under your imaging concept. You know what is a sampling and quantization. So here we can reduce the size of that image, the dimensions of the images by means of this. And quantization we can use to reduce the number of bits to represent our images, as well as it will help us to convert the analog images into digital images. And this sampling and quantization technique will help us to in image compression also. Then next to previous slide. Can you go back to the previous one? Yes. So image processing, then image enhancement and restoration technique. Image enhancement, you know that with improving the appearance of the images, we go for image enhancement concept. Here various image, for example, histogram equalization techniques are there. So how the pixel values are arranged or spread throughout the images, and how we will equalize the pixel values, how we equalize the pictorial representation of our images. So for that, image enhancement technique will help us to enhance the quality of an images for the better visibility. And the image restoration will help us to restore the images from its in its original quality. Suppose image is degraded by the different noises or different methods, we can distort the images. From that we can able to restore our images from the distortion. The next slide, madam. This is called image analysis. That is feature extraction and feature selection. So we need to extract an appropriate feature, and we need to select relevant features. That is most important concept. Here we can concentrate which algorithm is better suited for our application, and how we are going to reduce the dimension of the image, because the dimension of the image will impact in the dimensionality as well as in the computational complexity of our algorithm. If you want to reduce the computational complexity of our algorithm, obviously we need to reduce the dimension. To reduce the dimension, we need to identify only the relevant features. Instead of processing all the features, we need to identify the relevant features. And image representation and description and recognition and interpretation, here this is coming under our image understanding or higher level of our image processing, otherwise we call it as a computer vision system. So image representing a particular object in an image or recognizing a particular object in an image is a very difficult task for the for human. That is why we are depending on the computers. If you are developing an appropriate model or a system, computer vision system, that will obviously will interpret and it will understand a particular object in an image. So the prerequisite for computer vision techniques is our image processing. So image processing, first of we need to know about the image processing concepts, image processing algorithms. Then afterwards, we will go for a computer vision algorithms and computer vision techniques. But the prerequisite for this computer vision is our image processing. And I hope I have touched most of the important concepts in computer vision. It's a very introduction part only. So research part, I have given some of the ideas in which area we need to concentrate on. So many applications areas I have listed out. So there we can concentrate on our research. That's all from my side, madam. Hello. Hello.
Yes, sir.
Yes, madam. That's all, madam.
Okay, sir. Thank you, sir. Thank you. Thank you for your very interesting and thought-provoking session, sir. Good evening, all. Thank you is such a prayer that cannot be seen or touched. It must be felt by heart. I feel honored and privileged to get an opportunity to propose a vote of thanks on this special occasion. On behalf of our management, Department of Computational Intelligence, Sarita College of Liberal Arts and Science, convey deep regards and hearty thanks to our Honorable Chancellor of SIMARS, Dr. N.M. Veerayan Sir, respected Director, Academics, Dr. Deepak Sir, respected Director Madam, Dr. Ramya Deepak, and Vice Chancellor Dr. Suresh Kumar Sir, who inspires us to achieve our best. We desire to express our sincere gratitude to our Principal Madam, Dr. Gunita Arul Chandu, for the constant encouragement and continuous support for conducting this 5 days international virtual webinar as a faculty development program. I would like to thank all the invited speakers, Dr. A. Prema Krupakaran Madam, Mr. E. R. Ramesh Sir, Dr. R. Sujata Madam, Dr. P. Pushpalata Madam, and Dr. V. Thirunavukkarasu Sir of this 5-day virtual webinar. Words are not enough to thank their constant guidance and support to shape the conference. I am very much thankful to the head of the department who always stands by us and motivates us. I express our heartfelt gratitude to our dedicated colleagues for their tireless support. Finally, who have turned up in such a great number for 5 days session, not only from India, but also from other countries like Nigeria and Dubai. This is a huge success in itself. Thank you so much for your cooperation. Once again, I thank all for your cordial cooperation. Thank you.